So let's actually do an example of a centroid. So we're trying to find the centroid of this shape over here, like we were looking at before. So the first thing we do is define. So step one was define a 0, 0. So I'm going to define this at point here as 0, 0. Then what we did was break the shape into simpler shapes. That was step 2. So I'll basically break this up into 2 rectangles and a triangle. So step 3 was let's make a table. Done that. And then what we have to do is we have to find the area of each shape. So let's define this. This is going to be shape 1, this is going to be shape 2, this is going to be shape 3. So area 1 is equal to base times height, which is equal to 18 times 24, which is equal to, should be times 24, 432. Equals 432. So I just enter that in the area for shape 1. Okay, so then I repeat that for shape 2. So shape 2 is area 2, this one here, is going to be 12 high, 12 wide. This base times height equals 12 times 12, which equals 144. So that goes into area 2. Area 3 is a triangle. Area 3 is equal to half the base times the height because it's a triangle. The base is 18 long. The height is the height of that side, which is also equal to 18. So 162, let's go 9 times 18 equals 162. Okay, and then we had to find the distance from 0, 0, 0.00 to the centroid of each shape. So this one here is going to be half along, half up, so that's going to be 12 and 9. So the distance to the centroid of shape 1, just did it in green, is going to be 12 along. Centroid to shape 2 is going to be 6 from that edge to there, and then another 24 there. So that's going to be total distance of 30 for shape, because it's 24 plus 6. And then the third one, remember, centroid for writing the triangle is a third along, third up. So the third one is also going to be 6 along. So 6 plus 24 is 30, plus 12, 42. So distance is 42. Then what we do is we multiply these numbers together. Let's add up the total of that. First of all, let's find out what our total area is. Plus 124 plus 432 equals 738. Okay, then we go ADX. So this is going to be the area times the distance to the centroid for each of them. So 432 times 12 equals 5184. These numbers can get very large, quite reasonably into the millions. Times 30 equals 4320. And 162 times 42 equals 6804. And what we're going to do is we're going to add these numbers up, put them in this column, put down there. So we've got 6804 plus 4320 plus 5184 equals 16,308. That's cool. Now we're going to repeat this for y. We're going to work out the distance y. So for the first one, it's going to be 9 second one, it's going to be 6. And for the third one, it's also going to be 6 because it's a third of the height. This triangle is 16 high, third of that is 6. So these are both 6. And then we get the area, ADY, so we're going to multiply A by the distance in the Y dimension. So 432 times 9 equals 3888. 144 times 6 equals 864. And 162 times 6 equals 972. And then, just like we did here, we're going to sum these all up. So this is 972 plus 38 plus 864 equals 5724. Okay, so we've got a whole lot of random numbers now. Now we have to turn these into a result. What we need to do is we want to find out the centroid. So centroid, let's try that again. Cx, the centroid in x dimension, is equal to the sum of A dx over the sum of A. Now this number here, 16,308, is the sum of all these added up together. So I'm going to stick in 16,308. And A, some of that is this number here. We add those up, so we go divide by 738. So we go 16,308 divided by 738 equals 22.10. Then we repeat the same thing in the y dimension. Cy is equal to sum of A dy, so this number down here, divided by sum of area, so divide by that number, so it's 5,724 equals, divided by 738 equals 5724 divided by 738 equals 7.76. So now we can draw this on this figure over here. We come along 22 millimeters, so about there, 22.01. So this is going to be Cx. We go up nearly halfway, Cy. Just like when you're doing a graph, we connect the dots, and the centroid of that figure is going to be there. Cool. So once you've done this a few times, it does become fairly mechanical. It becomes a mechanical process. The big thing is we have to work out the areas of each of these things. We have to measure the distance. We break it up into simple parts and work out the centroid of each simple part. And we measure that distance to that centroid from a single point. So this point here, all the way up here, up to here, all the way up here to that point. And then we repeat it up here. So then we multiply the area times the distance. This is figure. Area times that distance, and area times that distance to get the complete number. Add them all up, divide ADX, so we divide this number by this number, that gives us the x dimension. We repeat in the y dimension, where they meet, that's where the treasure is. Woohoo! Okay, so we'll do a more complicated example next up with a hole in it.